Next would be classification according to purpose. According to purpose, concrete is classified in the following types. First, the vacuum concrete, air entering concrete, and lightweight concrete. First would be the vacuum concrete. So, ang sabi dito, the cement concrete from which entrade air and excess water is removed after placing it by suction with the help of the vacuum pump is called vacuum concrete. Although may advantages ang vacuum concrete such as pinapataas ito ang compressive strength, lowers permeability, and it gives a smooth and clean finished surface. The inherent porosity of the concrete allows water and oil and even grease to seep through consistently, weakening the concrete. Next would be air entering concrete. In this type of concrete, bubbles of hydrogen gas are liberated which forms cells and make the concrete cellular. So may magtatanong, bakit kailangan mo ng hangin sa loob ng konkreto mo? Di ba kailangan mo maging solid to? So in some places na mababa ang temperatura, water within the concrete capillary pores will freeze and expand when the temperature drops below freezing. If the concrete is critically saturated, the expansion of ice exerts pressure within the hardened concrete and will cause cracking if the tensile strength of the concrete is exceeded. So if merong hangin sa loob ng concrete mo, it will provide a place for the freezing expanding water to move into, which relieves the pressure and thereby prevents cracking. So last would be the lightweight concrete. This concrete prepared by using coke breeze, cinder, or slag as coarse aggregate is called lightweight concrete. The concrete is light in weight and possess heat insulating properties. Okay, so since mababa ang thermal conductivity na ating lightweight concrete, pwede natin itong gamitin to insulate water pipes, walls, or even rooftops. Ngayon punta naman tayo sa factor controlling properties of concrete. First would be grading of aggregates. Aggregates play a huge part in the concrete. Aggregate influence the properties of concrete such as water requirement, cohesiveness, and workability of the concrete and plastic stage, while they influence strength, density, durability, permeability, surface finish, and color in hardening stage. Next naman is yung influence ng water content sa ating cement and aggregates. So as you all know, moisture content plays a huge part in determining the properties of the concrete and aggregates. If there is a moisture content, there's water, and if there's water, there's pressure. The appropriate amount of water is needed to avoid excess pressure that may force any unreacted moisture to the surface of concrete and create a non-conductive substrate condition, ultimately leading to coating adhesion failure. So as an engineers, iniiwasan natin yung coating adhesion failure. Bakit? Kasi it indicates that the entire surface was not treated correctly or that it has a small spot or has a problem. Proportioning of the various ingredients of concrete. So hindi naman siya kabod magiging concrete. May mga ingredients yan such as cement, water, sand, gravel, or even air katulad ng na-discuss natin kanina. And hindi mo rin siya pwedeng paghalo-haluin ng kung ano lang gusto mo. We have to follow different set of ratio depending on the structure that you want to build. Placing and compaction of concrete. So as the name implies, compaction of concrete significantly increases the ultimate strength of concrete and it enhances the bond of the reinforcement. So after we mix the ingredients of the concrete and set it aside, we need to make sure that it will reach its peak strength. So how do we do that? Dito na papasok yung process ng concrete curing. So ito yung process of maintaining adequate moisture in concrete with a proper temperature range in order to aid cement hydration at early ages. A properly cured concrete has an adequate amount of moisture for continued hydration and develop of strength, volume, stability, resistance to freezing and thawing, and abrasion and scaling resistance. So as I have said earlier, hindi mo pwedeng paghalo-haluin yung concrete mixture kung anong ratio yung gusto mo. Meron tayong kailangan sundin depending sa structures na itatayo mo. For example, sa concrete column, 1 part of cement, 1 part of sand, and 2 parts of aggregates. Sa water retaining structures naman or dense concrete, it would be 1 to 1.5 to 3. For RCC beam slab column, it would be 1 to 2 to 4. For mass reinforced works, it's 1 to 3 to 6. And finally, for mass concrete work, it's 1 to to 4 to 8 cement, sand, aggregates respectively. Finally, water-cement ratio. So we have a different water content we need to add to our concrete mixture. Our basis would be 50 kg cement and it is as follows. First, for the concrete ratio of 1 to 3 to 6, we add 34 liters of water. For 1 to 2 to 4 rather, we use 30 liters. 1 to 1.5 to 3, 27 liters, and finally 1 to 1 to 2, we use 25 liters. We need to be mindful to our water-cement ratio as it controls the mechanical properties and durability of the concrete. Any less or too much water will reduce the strength of the concrete.